Hey, welcome back to the Build It Basement. You are watching number 9 of the Voron 2.4 build in a series of live build videos, kind of a tutorial slash see the mistakes I make, make sure you don't make them yourself. I do suggest everybody builds a Voron if they get the opportunity to do so. If not a Voron, something else. A lot of fun. You learn a lot. If you're at all into 3D printing, it's definitely worth it. So, taking you with me here to do this build, we're moving on to the Afterburner, which is honestly pretty awesome looking. So we left off, we had the gantry all finished off. We're now at the point where we're starting to build the Afterburner, and the section that we're going to start off with is the rear side of it, the actual side that's going to clamp onto our belts. I've gone ahead and I've already put the nuts in these, and the heat heat sets, whatever you want to call them. So those are in there. I do have a video on that, so if you're at all interested, if you have any questions on that, you can look back at my other videos. I do have one on putting those in specifically. Let's see here. So we're going to be using our two rear pieces. Heat sets already in them. Two M3 by 30s and the two nuts. And basically these two parts are going to meet up like that. Let's actually bring this in like that. All right. So the holes used on this part are it's actually like this. And these are keyed, so they do fit together. So you can feel that. You have a nut here and a nut there. So basically you have your end of the bottom, the leg of it all, the foot, if you will, which does not have anything in it. The one next to it does. And then the very top hole next to the groove here as well. So on the flip side of that, these pieces will be a little slippery for me tonight. We'll go ahead and put that first M3 in there. Let's get that started. And our second one right here. Like so. And do keep in mind that this is plastic on plastic, so I have this turned way down. We don't want to draw our nut through the plastic, and we don't want to pull our head through the plastic. We want this enough to kind of set it where it needs to be a solid piece, but not more than it needs to be. From here, we are moving on to our probe and pivot block. So the Voron specifications are for an inductive probe. If you're not sure what an inductive probe is, I will give you a little quick rundown on that. If you're familiar with a BL Touch, which is actually a touch probe, this does the same thing, only it is basically using inductance to be able to tell how far away it is. So think of it kind of like a metal detector. If you have a glass bed and you didn't have enough metal underneath that glass bed, or if there wasn't enough structure there, an inductive probe would not work very well. So what this does is it basically has a coil inside of it, and when it gets, basically the resistance will change based on how close it is to that metal. Again, similar to the way that a metal detector would work. So unlike a BL Touch, it doesn't physically touch anything. It doesn't need to. It is set basically to how far it is away from something. So it's a measurement device that does not need to touch something, which has its positives in the sense that there's no wear parts, there's no moving parts in here whatsoever. So this should last nearly forever as long as we don't burn it out electronically. So, all right, according to, let's see here, we have our piece facing forward. Gonna go to the rear side of it. That's where our heat certs are. And this, kind of hard to tell, but basically it does have a rib right here that sticks up and it's flat on the back. The flat surface is facing towards the back, the rib part facing upwards in this set, and then basically your cord, your wire, is going to wind up going through like this, and that's what that groove is for at the top. This is going to be attached utilizing let's see here, the small flat portion, also with sets in that, and that's attached using two M3x20s, which I have right here. So this is going to allow for you to mechanically adjust how far down this unit is. If I can get my fat fingers around it, we can get that done. Okay. And for right now, you really don't need to tighten this up very much. I'm actually going to take mine and I am going to place it as low as it will go. Hopefully stopping me from forgetting it. So that's set like that. This wire is going to go through like this, and that's what that is. All right, back to the screen. Back to the assembly manual. All right, so here the next portion that we have are the two clamps for the actual belts that are going to come through on this piece. On the inside here, we have a groove portion right here and right here, and that's to hold the belt. These pieces are going to basically be pushing against that with the belt to hold them in place. These are going to be held in with these M3x12s. So get that on there. Again, you definitely don't need these tight right now. We don't have the belts on here yet, so it's not going to help us at all to have them too tight. So like that, they're in place. All right. Now, the fun stuff. So they want us to mount the carriage to the actual gantry. So it says here, button head option. If you have some M3x8 button head lying around, you can use those here. It can make belting the gantry in later steps a little easier, but it's not a big deal if you don't have them. Okay, good tip, I guess. So we'll go ahead and get our gantry back. Place that like that. It's kind of neat. And let's see if we can get that to a place where you can kind of see what we're doing. So this is going to get mounted with the inductive probe facing downwards. So that should be You're looking at the top, I'm looking at the bottom. So that should be something like this. Actually, go back to that view right there. That might be a little bit better. A little closer there. So basically, I got my two rails right here. This actually sits right on top. It fits like a glove, to be honest. Maybe it's beginner's luck, or maybe maybe I don't know what I'm getting into. We'll see. So we're going to need some M3x8s for that, which I thought I had already pulled, and I do. So let's see here. We're going to need 4 of those. 1, 2, 3, 4. I'm actually going to pull my wire back a little bit here and see if I can line these up. It's actually starting to turn into something at this point, right? Just as a side note, anybody that's been watching, anybody that's subscribed, those folks give me a thumbs up. I do appreciate all of it. I would like to continue with this channel after this Voron build. The build portion of this is actually just a start. Once we get done with the build, obviously I got a lot of wiring to do, which is not in the manual. So that may be very helpful to a lot of folks. I also plan on doing some step-by-steps with Clipper and some other items as well. So if you haven't subscribed, great time to do so. And let's see here. Now that we have that attached there. All right, now we have a little pivot point. And what this guy allows to happen is basically it's going to be sitting, which is kind of odd that they had me do that first. Oh, I guess we got to detach that. So that's actually going to sit on the other rail, and it allows for some very slight movement. I don't know if it's just because the expectation is that the rails aren't 100% aligned, but basically this goes in like so. It has a hole in the middle, a key. These are beveled on the top end, so that fits in like that. And that's going to be held in place with an M3x30. Okay, M3x30. And that is going to be, I'm looking at it from that direction, that's going to be like this with the screw facing this way. Okay. I have not put that nut in yet. Another little quick tip, if you like quick tips. So one of the best ways to get nuts in, since most of these things are pretty tight, is just thread that nut onto the screw that you're going to use. You know, just a couple turns, 1 or 2, that's all you really need. Get on there like that, and then get your part, your piece, and you have a method now to insert that nut straight, unscrew, and you should be good to go. That will help you ensure that when you do screw into that nut, it is not all wonky. It's a great word. I guess it would help if it was just slightly deeper. Or maybe it's just going to fight with me. There we go. There we go. All right. So that's just tight enough to put it where it needs to be. Again, I don't know how much movement that's really going to get in the scheme of things, but that's the way they want it. So put this back the way it was. Put my screws in here again. Go. And then put that back. And put our 4. Again, we have 4 M3x8s going in the back side of this for the double rail. And I mentioned it when I was putting this together that there are some notes to only use a single rail. There's some logic behind that in terms of stress and the fact that aligning two things perfectly straight is near impossible. On the opposite end of that spectrum, you have the argument that it's going to be a lot more stable if you have 2 of them on there. I will say, as of right now, there is some considerable drag on there. It's not terrible, but there is some drag on there. So that might be something we can adjust a little bit by these wires, I tell you. Probably just a little bit by loosening up our rails ever so slightly. You know what? Why don't we try that right now? Why not, right? If it doesn't help, we can always put them right back to where they were. So the thought is, if these are, oh, there we go. Oh yeah, that is a ton better. So what I'm going to do, and this is nowhere in the manual, so just testing this out for myself. Don't know if it's going to work or not, but I'm actually going to use the base of our afterburner as a guide as to where the rails should be. I'm leaving one permanently affixed tight where it was. The other one is just ever so slightly loose. And it's going to run that down as I go. I can see right now, as soon as I tighten that down, it actually gave me some difficulty there. So let me see. Oh, that's interesting. All right, let's do this one. This is about where we started with, so I guess that did not help me at all. Using these guide tools, that's still right about exactly where it was to start off with. So what I'm going to try now is to loosen up this other rail ever so slightly. And again, that's way better. Okay. Do one end. I'm going to slide over to the other end here. Put myself real close. Work my way down. I will say definitely has more drag than a single rail or when the rails are loose, but that is probably half of what we started off with. So that'd probably be a good note if anybody wants to do both of their linear rails. So, all right. Back to the screen. All right, do not tighten yet. Leave these loose. You'll need to align the rail before tightening. See Discord, can you help with the correct procedure? Oh, interesting. Okay. So they didn't want me to tighten those very much. Let me see if I can tell you it makes absolutely no difference to my eye, to my ear, and to my hand. So we're going to go ahead and tighten that back up. Yeah, it's not that bad. All right. Let's see now. Okay, so we're at the belt portion of the build here. And my plan is to skip over this for now and continue with the actual afterburner as opposed to doing the belt. Hey, Keeg.
Hey.
What you doing?
Oh, I just came down to say hi, pretty much.
Oh, yeah?
Mm-hmm.
All right. Time for bed?
Pretty much.
Want a hug?
Sure.
All right. Oh, have a good night.
Yeah.
I'll be up in a little bit.
Okay.
All right. Love you.
Love you. Bye.
Bye. All right. So we get that. Let's get back to this. Sorry about that. So I am going to do a video on the belts, but I'm going to do that all in one shot. And that's going to take some routing that I don't want to put into right now. So we're going to continue on, like I said, with the hot end and with the afterburner. It doesn't look like it's going to change our course very much to not do the belts quite yet. So that's my plan. Hopefully everybody's good with it. So we get down to the shroud parts and the hot end and the back, and in a previous video I had talked about the drag and hot end. So go a little bit further into that here for a moment. So the drag and hot end is a lot like the Mosquito. It's not exactly the same, but it's enough that someone got upset and sued somebody else. So these may be hard to come by at this point, but it should be the same as the Mosquito version of this. So this comes with a slot mounted system. So basically this comes with this portion mounted to the top of it This comes off. It's held on by 2 screws, and basically you wind up with 4 screw holes here at the top of this. Get rid of that. So the actual instructions show an E3D hot end. And we're veering slightly off of that. One did come with the kit. So if you are going straight up with what the kit came with, you're going to wind up with a clone of the E3D. There's nothing wrong with it, but I thought this was a good opportunity to spend a tiny bit of money and get a good upgrade. Again, nothing wrong with that. Go ahead and use that if that's what you're using. That's what the instructions show. That's part of the spec. But this is one of those little specs that are part of this build that aren't concrete. They're not set in stone. A lot of different people have different reasons for using different hot ends. I plan to play with some materials that I think this will help me with. So that's why I'm going with that hot end. All right. So I already got my heat sets in there on that side as well as that side. So that top picture that you're seeing is showing these. The middle bottom picture is showing these. And then basically our assembly I just dropped a screw. Alright, well, our assembly on this looks something like this. So this is going to mount using the screw holes, and this again is a different part. This is available, it's in the STLs. You print basically based on the hot end you're going to use. This one has the screw holes at the top to use the screw holes mount for the mounting of this on the top, as opposed to just clamping shut on it. Which is another reason to go with a hot end like this. It's more of a mechanical fit as opposed to just a friction fit. Not that there's anything wrong with the other one, but just one of those things. So the way this is going to go is we're going to be putting this in like this, and like that. One thing I'm not 100% on is the direction. I feel like it's notched out to go in like this. That's the way I'm going to go with it. So we'll start off by getting our M3x40s and our M3x16s. M3x40 and M3x16. So we need 2 M3x40s. And then 2 M3x16s. And 5 M3x16s. There we go. All right. And basically the longer 40 screws are going to the bottom, the shorter screws at the top. So something like that. Start those. These are going to go through there. long on the bottom, shorts on the top. Tighten these up. And that leaves us with the screws. These actually come with the hot end, so I know they will be the right ones. What I don't know for sure is what size that is. I guess take those up for a second. Let's see. Line these up could be a little fun. That's right. Allen key for that. Nope. Let's see, where are we at? There we go. Alright, see if we can get the first one started. Yep. Alright. Second one started. Yep. And 3 and 4 should slide right in. Okay. Alright, kind of odd. I got a little bit of a jiggle there. I may have used screws that were too long. So, let's open up this bag. I have these guys right here. I think we might be bottoming out with those screws before we actually get that tightened up. So let's take one out. There we go. Let's try one of these guys. Yep, much better. Okay. It's always good to catch your mistakes before you get too far along. Especially when the whole world can see what you're doing. Or else you gotta put out another video with a mistake fix and sit there and admit your faults and act like you're still having fun doing it. So with the additional screws that came with this hot end, the Dragon hot end, there are some longer screws and some shorter screws. And you're going to want to make sure you use the slightly shorter screws, and I will give you a measurement on those. Screws that you want to use are about 10 millimeters. So, the 10 millimeter screws. I'm sure there's probably a document someplace that says that, but you could spend a lot of time looking through documents trying to find out random little bits of information. Go. And then number 4. What I don't see, and I'll have to look into, but I am curious of, and it probably has to do when we start working on the extruder, is I'm assuming that there'll be a section of Capricorn or something going in the top here for our filament feed from our extruder. It's pretty, ain't it? Alright, so we still need that. I can get these things put away. These parts that we do not need. And just for reference, these are the little guys that are in the hot end that are holding things together. It's kind of hard to see against the black. Very small. So. Alright. And shove that away. Oop, one last piece. Did a little video on this. It wasn't too much at all, but I do have a video for this hot end. That package is really nice. The hot end seems really nice. Kind of a shame people get too happy, but it's the world we live in, right? All right. So with a slight modification to that, we're moving on from there to getting back to our carriage. So test fit housing, make sure to test fit the hot end housing. It should be able to slide in with firm pressure, but not be loose enough that it can wobble. Okay, I'm not sure if it actually wants to attach this or not, but I'm going to assume they do. So it looks like we're using some M3x16s on that. 3x16. 2 of those. And we are getting down low on those. It's kind of fun when you get into a project with a lot of pieces and parts, and it's a little scary when you get low on certain pieces and parts. It makes you wonder if you have enough, but at the same time you're like, gee, you know, there's an end to this. You actually get something out of it. So they are showing, actually they're showing 2 things in that picture that I find interesting. One is they're showing some tube coming out of that hot end, which I don't currently have, but we'll see where that lands us. And they're showing the part going on there. So let's see here. Oh yeah, there was that too. That was interesting to me. So this is sitting on there like this. Which makes me think that we should have flipped that around. So feel free to fast forward about 1.5 minutes while I flip this around. And also feel free to save yourself the hassle if you're watching this and you're building with the same hot end. One more mistake that I make, where you get a 50-50 chance that you won't have to. Should be worth like a like, right? So if you think of it, go ahead and hit that like button. Look how I work that in. Okay, flip this guy around. So just for reference, on the bottom of this, the portion with the thread, with the inserts, this has a bevel to it. I am facing the bevel portion towards the threads, the inserts. So that to that. And hopefully that resolves my issue I just had a moment ago. So the issue I was having, in case you're picking this up after, is that the end of my hot end on my, I almost said mosquito, on my Dragon, because it's longer on one side than the other, was actually touching the inductive probe. And one, you don't want that much heat up against that. And two, it was stopping me from actually mating up the portion that's on the carriage to the hot end portion. So I couldn't have that. Okay. I've had two thoughts while I'm doing this build, specifically on screws and plastic. One is, what is enough and not enough in terms of torque on these? And two is, by pulling them in and out, are you causing the plastic to weaken? I don't know if anybody's done anything about that or thought about that much, but kind of fallen in my head a couple times on that. So the longer M3x40s that we first put in a few moments ago that were falling out for me, actually are what holds the bottom section of this to the carriage section. So that top section is being held in by the M3x16s, but the bottom section is being held in by the screws that we already kind of put into place. So it's going to be kind of hard to show this, but I will attempt. This portion of the carriage actually touches on these little nubs sticking out, and it actually holds it in place. And actually, without even any screws in there, it's pretty positively locked in. So go ahead and tighten these up real quick. And then again on these. These are a little difficult. Let's bring this back around again. Just get a better view. I'm wondering what those are actually screwing into, because I think those are just screwing into plastic. There's nothing in there, and there's nothing on the back side, so I don't believe those are actually screwing into anything. So the majority of your mounting is actually happening here as opposed to back here. But there's additional mount points up here that you're probably going to wind up using here at some point. Man, that's cool, right? Actually, something coming together. So this design too, I'll point out while we're here. So, let me get that zoom in to focus. This is 100% open on the inside. It's pretty thin. So it's doing two things. One is it's moving cold air from this top section through this complete area so that your hot end actually doesn't heat up the plastic too much. So that's plus. That's on top of the fact that you're going to have a fan blowing through the front here. So you get that cooling effect from there because this is ABS. It's not metal. Plastic there. And then secondly, you have a nice wide and direct flow right where you're extruding from. So if you're using material that needs a good amount of airflow around it, that should facilitate it. Very nice design. So kudos to the dev team on that one. So, clockwork heat sets. So we're getting into the extruder at this point, and that's where I'm going to call this. So I'd like to thank you for coming in, watching what I'm doing. If you haven't hit that subscribe button, please do. Give me a like if you like what I'm doing. And if you don't like what I'm doing, leave me a comment, I've had a couple of people that don't like what I'm doing. Don't know why. Just let me know. I'll do what I can to improve. Till next time, comments, likes, all those good things. Let me know what you want to see. Let me know what you didn't see enough of. Let me know what I screwed up. And next time we'll be putting together that extruder. See you later.